Okay, this is yet another problem where you're trying to solve for x, which is in the exponent position here and here. But what's unique about this is that it matches a certain form. These are called quadratic um, exponential equations. And so the form is that the exponent x is twice the size here and just a plain x here and missing here. Three terms. Quadratics all have three terms. A, if there is an a in front of the x, and that x has a power of 2. B, and that is just x. And then the third is a constant. Well, this fits that form. So how do we solve it, though? Because we're not solving for x. Okay, that's kind of normal. The x is now an exponent. X is up here. It's up here. So it has a very different role. The way to solve this is by using substitution. Okay, I am going to create something, and I'm going to call it u, such that when I use the u, I'm going to have the u is going to be what we called the x in the quadratic equation, in the quadratic form. 3u squared. It's going to look like this in the end. 14u plus 40 equals 0. And I'm going to solve for u. But where did the x go? The x is an exponent. And what you're going to look for when you construct this u is that they both have the same base. And the x is an exponent on that base. So u is 3 to the x. Okay? U is 3 to the x. And if you've done this right, if you square the u like this, u squared should be 3x, which is u, squared, which means multiply that exponent by 2. Well, I wrote x times 2, but it's the same as saying 2x. That's exactly what this is. So I'm good. And u being 3x, this next part, that u shows up right here. It's negative 14u. Well, u is 3x. 3 to the x. I should be saying 3 to the x, not 3x. It's 3 to the x. Plus 40. Okay, so this is the new equation, and the key step here is the substitution of u for the base to the x. Okay, and you won't have to worry about solving for this until the last step. So let's do it on a clean piece of paper. So as we talked about, what you want to say is off to the side, u is 3 to the x. Okay, and then as we did, we're going to say we're going to use the u, and instead of, oops, we're just going to say 3. Sorry, I should be saying u. We're going to say u to the second power, because u to the second power is, here's the u, 3 to the x to the second power. That is 3, and I'm going to multiply these two powers, 3 to the 2x, which is what that is. Okay, so u squared makes that happen. And here's 14, and I'm going to say u because there's my 3 to the x, which is u, plus 40 equals 0. Okay, so let's Let's solve this. Let's factor. So we got 40 on top, negative 14 on the bottom. So I think we can work with negative 10 and negative 4. So factored, we got u minus 10. There's nothing here. So I can just go ahead and plug these values in. And u minus 4. So solving for u can be 10, which will make that 0. U can be 4. Okay, so these are two solutions to this equation. But now we're going to go and substitute back 3x for u. So let's write these again. 3 to the x. 3 to the x is 10. 3 to the x is 4. How do you solve for x? What you do is write this as a log statement. Okay, and a log statement has a base, log base 3, because this is the base. And remember, what is a log? What even is a log? It's an exponent, right? And it's the exponent that gets you from 3 to 10. So that's just been rewritten, okay? And we can do the same on this side. Log base 3 of 4, which is kind of the destination, 3 to the x power gets you to 4, and that's what the log is equivalent to. So right here, we have what x is. This is a number, and that's a number as well. Another way that I see that Delta Math explains it, if you say 3 to the x equals 10, and I want to know what x is, they talk about taking the log of both sides. Well, log base what? If you take log base 3 of this, 3 to the x power is what gets you to 3 to the x. So that becomes x. In a sense, log of this base and that base, you can say they cancel out. But if you've taken the log of this side, you've got to take the log of this side as well. Log base 3 of 10. And you can see that, this is equivalent to this. Okay? So different ways that you can think about it. There's the kind of writing this statement as a log statement. There's also taking the log of both sides, but taking it with the base that matches that base. Okay, whatever makes more sense to you. But the answer is we need to put this into our calculator to get one of the x's. We need to put this into our calculator to get the other x. Oh, and guess what? This is an old style calculator, like a lot of scientifics are. It doesn't have log of any base, but don't worry, there's a simple solution to that. What you do is just say log, and there's the button for log. Log of what you want, and then divide it by the log of the base that you want. So this number is log base 3 of 10. It's a shortcut. A lot of old calculators couldn't handle logs of any base, so you had to kind of use this trick. 2.09 rounded to 3 decimal places. So 1, 2, 3. Oh, I got to trip that up to 6. 2.096 was one of them, and the other one was log base 3 of 4. So I'm going to leave that base log down there and then change that. I got 1.2x, 3 decimal points. So decimal places, 1.26, 1.262.